purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 6, extending place value, and working with decimals to solve problems. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 6. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of this video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has two AKS. Under the AKS, you will find the Indicators of Achievement, or IOAs. Take note that we focus more on the IOAs because in order for students to show mastery of an AKS, they need the building blocks of the IOAs. You will also see that we have provided you with the state coding at the end of the IOAs so that if you were looking up resources on the Georgia DOE website, you are able to find the state IOA that is related to the GCPS IOA. In Unit 6, students extend their understanding of the place value of numbers to include decimals through the thousands place. Then, students use their understanding of place value to locate, compare, and order decimals to the thousands place. Students will use place value reasoning to round decimals to the tenths and hundredths places. Lastly, students will extend their understanding of whole number operations work to add and subtract decimals, utilizing familiar representations, strategies based on place value, and properties of operations. Students will continue to ask questions and answer them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. Our first AKS in this unit, 5MAA.4, has 4 IOAs. IOA 4A extends the work in 4th grade with decimal place value to the thousands place. Students will read and write decimal numbers to the thousands place using base 10 numerals written in standard form and expanded form. Students read and write decimals using appropriate math language. Writing decimals using expanded form includes fractions to show place value. Students are not expected to write decimal numbers in word form. Decimal numbers can be between the millions and thousandths places. With IOA 4B, students represent, compare, and order decimal numbers to the thousands place based on the meanings of the digits in each place from relevant mathematical situations. Students determine and explain comparisons using a variety of tools such as concrete materials, drawings, number lines, and other visual representations and strategies. Students use greater than, equals, and less than symbols to record the results of comparisons. With IOA 4C, students extend previous work with rounding to round decimal numbers to the hundredths place. Students understand the usefulness of rounding through practical mathematical problems using visual aids, such as a number line. The expectation is for students to develop understanding of place value and number sense, as well as the ability to use reasoning when comparing rounded answers to exact answers. Students will round decimal numbers to the tenths place and the hundredths place. Please note that this IOA does not extend to rounding decimal numbers beyond the hundredths place. With IOA 4D, students add and subtract decimal numbers to the hundredths place using concrete models, drawings, strategies based on place value, properties of operations, and the relationship between addition and subtraction. Students relate a strategy to a written method and explain the reasoning used. Students use estimation to determine the reasonableness of sums and differences and to check the correct placement of the decimal point. This IOA is not limited to the standard algorithm. Ultimately, students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. Our next AKS, 5MAC.7, has 4 IOAs. In Unit 6, the focus is only on IOA 7B, in which students analyze graphical displays of data to answer relevant questions. Students will ask questions and answer them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. Pacing guide is an example intended to model how instruction of the AKS IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of your students. Unit 6 has a suggested pacing of about 4 weeks. There are 21 given days of instruction on the pacing guide, including the Unit 6 assessment. Take note of the bullets on the left side of the pacing guide. These show the learning progression of the AKS IOAs for each unit and suggest manipulatives and tools. For Unit 6, you will need base 10 blocks and/or place value discs. Place value charts and decimal grids have been linked into specific resources on the pacing guide. Unit 6 opens with 3 suggested instructional days of IOA 4A. The pacing for this IOA will progress from concrete to representational to abstract. Students will use base 10 blocks to name decimal numbers in standard and expanded forms. Base 10 block pieces can be used in different ways to show the relationships between numbers. As long as the whole is identified and agreed upon, students can use the pieces flexibly to show decimal numbers. Base 10 models will reflect previous understandings that each place value is 1/10 the size of the place value to its left. As students transition to representational thinking, the focus shifts to matching a base 10 representation to its standard and expanded forms. For abstract, students record numbers given orally in standard and expanded forms to complete a chart. Unit 6 continues with 4 suggested instructional days of IOA 4B in which students represent, compare, and order decimal numbers to the thousands place based on the meanings of the digits in each place, using greater than, less than, and equal symbols to record the results of comparisons. Students will first experience comparing concretely by building base 10 block models before transitioning to representational models to order decimals. Representational models can include base 10 drawings, number lines, and/or decimal grids. Even though students will only experience comparing in isolation for 1 day in the progression of this IOA, students continue to apply the same strategies when ordering and comparing decimal numbers. Students are just extending the work of comparing to more than 2 decimal numbers. Just as with IOA 4A, abstract thinking will have students record numbers given orally as numerals and in expanded form to complete a chart using greater than, less than, or equal symbols. Students will then progress to 4 suggested instructional days for IOA 4C, where students will use place value understanding to round decimal numbers to the hundredths place. Please note that although IOAs 4A and 4B extend to the thousandths place, this IOA only extends to the hundredths place. Concrete experiences include using base 10 blocks to round decimal numbers. Students will then connect base 10 block models to the number line. With the number line, students will use benchmark numbers to round. At the abstract level, given any number containing decimals, students round them to any given place. Students who are taught to round decimals by using a rule rather than place value understanding have difficulty determining places when rounding to benchmark numbers. The final 8 days of Unit 6 will focus on IOA 4D, where students will solve authentic problems involving addition and subtraction of decimal numbers to the hundredths place using a variety of strategies. This IOA is not limited to the standard algorithm for addition and subtraction. Students use base 10 blocks to demonstrate regrouping between place values. Students then progress to using decimal grids that represent one whole to represent decimal operations. Students will also explore using number lines to add and subtract decimal numbers. Abstract thinking will shift to the standard algorithm. Estimation is used to check correct placement of the decimal point. Again, students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. Unit 6 ends with IOA 7B and an investigative research task in which students will justify the use of technology and human interventions when they were used to prevent situations where destructive and constructive processes occurred. This Georgia DOE task is a PBL and will require multiple days to complete. It integrates Science AKS taught during Quarter 2 with IOA 7B, where students ask questions and answer them based on gathered information, observations, and appropriate graphical displays to solve problems relevant to everyday life. On the right side of the pacing guide, you will notice a number of provided resources aligned to the bullets on the left side of the pacing guide. Throughout the pacing guide, you will notice different lesson types: traditional, teacher-directed instruction, and task-based learning. For days where a task-based lesson is provided, you will see a blurb above the linked lesson. Additionally, you will see resources that have been pulled from the adopted Georgia Reveal curriculum for 5th grade. These resources are not directly linked, but can be accessed via the GCPS portal. You will see examples of lessons that have been adapted using the Georgia Reveal components. Resources from the Georgia DOE have also been adapted and linked to the pacing guide. Some Georgia DOE resources have been directly linked. The Analyzing the Standards documents, or ATS, provide teachers with an overview of specific instructional strategies progressing from concrete to representational to abstract. The ATS for each IOA is linked to the pacing guide at the beginning of each unit. These can also be found on unit pages on eComm, and you may also notice that the ATS has been linked to the top of each lesson plan provided on the pacing guide. We won't be looking at every strategy from Unit 6 in this video. For this video, I will be modeling strategies for each IOA discussed earlier in this video. The first strategy I am going to model is for IOA 4A, read and write decimal numbers to the thousandths place using base 10 numerals written in standard and expanded form. I'm going to use base 10 blocks to build a model of this decimal to help me better understand the value of each digit. When I have used base 10 blocks in the past, I have used them to represent whole numbers. In this case, I'm going to use the large cube to represent a whole. The flats will represent tenths. The rods will represent hundredths. And the small unit cubes will represent the thousandths. So you may be saying to yourself, well, this is going to be very confusing for students. It can be, because students are very accustomed to using base 10 blocks to represent whole numbers. In this case, we're going to be using them to represent decimal numbers. So an anchor chart is a really helpful tool to support students with this information, since you are redefining the whole for students compared to when they use base 10 blocks to represent whole numbers. So let's go ahead and begin building our model. I'm going to slide this down just a bit to the bottom, just so I have a little bit more space to work. So I can see that there are 4 ones in the ones place, or 4 wholes. So I'm going to use 4 large cubes. I'm going to kind of pull them over here to the side. You'll still be able to see them, just they're so large, and I'm going to need some space. So I'm going to pull 4 cubes to represent those 4 large cubes. So again, I want to remind my students that these represent the whole. Perfect. Let me get that a little bit straighter for you. Perfect. All right. So those represent my whole. So I'm going to write in expanded form as I go along. So 4 ones, I have 4 wholes, or 4 ones. So I will write that simply as 4, and then I'm going to put a plus sign. Because remembering, I am going to write this in expanded and standard form, but right now I'm focusing on expanded form. So next I see I have a 6 in that tens place. And again, in this case, I have defined my tenths as the flats. So I want to remind students again, connecting to what they know about powers of 10, 10 of these is equivalent or equal to 1 of these, or this is 1/10 of the whole. So the whole again is the large cube. So in this one, I have 6/10, so I'm going to lay 6 flats. I'm going to kind of lay them side by side here so I have enough space. One tip for you as you are modeling this with students or students are practicing this when you take on this particular concrete lesson is consider maybe lowering or the size of the ones place to maybe a 1 or a 2, and students could partner up with base 10 blocks just to make sure you have enough resources available. So I have 6/10, or 6 flats, 1, 2, 3, 4, 5, 6. And so that's a 6 in the tens place. So how do I write that? Well, I'm not focusing on my ones place this time, but so I'm going to put a placeholder for that ones place. I'm going to use a 0. That's me acknowledging that there is a ones place, but right now my focus is on the tens place and its value. The decimal does not move. This is a good time to tell students our decimal doesn't slide, it doesn't shift. Only the value of the digits could change if we move them, but we're not moving any digits this time. So we want our students to know that that decimal point is always between the ones and the tenths. So it's right after my ones, and I have 6/10. So that first place after the decimal point. So we'll write it. It looks like 0.6, but we want to move away from saying 0.6 and have our students say 6/10. So we want to model that as well, because part of this IOA is for students to read and write decimal numbers. So right now we are practicing writing it in expanded form, but we also want to be able to read the decimal. So that decimal is 6/10. I'll put another plus sign. Look at my next place. I have 1/100th. So I am going to, again, if I was doing this in the classroom, I would refer back to my anchor chart that defines the rod as my hundredths place, because I know that I need 10 of these to equal 1 flat, and I need 10 of these for this. So this is 1/100th, the value of the whole. My whole is the large cube. So in this case, the hundredths place, I'm going to follow the similar pattern to what I did here. I still need to acknowledge my ones place, even though my focus is on the hundredths. That decimal is right after the ones and before the tenths. I'm going to put a 0 in the tenths place because, again, I'm only focusing on the value of this place. So you can see there's my ones, my decimal, my tenths, and I have 1/100th, so I'll place a 1 to represent my hundredths place. Again, I would read this as 1/100th and not 0.01 or 0.01. We want to make sure our students are saying it in decimal notation. Part of this IOA. So one more plus sign, and I have 8 in the thousandths place. Again, I would refer back to my anchor chart for the value of each base 10 block since it changed for decimals. And I will need 8 of my small unit cubes. So there's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So I've built my decimal number here. Let me go ahead and write those 8 thousandths in decimal notation in expanded form and read it. So again, placeholder 0 for my ones place, placeholder 0 for my tenths place, placeholder 0 for my hundredths place, and my focus is on the thousandths and its value, and it has a value of 8 thousandths. So if you see, I would not read this as 0.008. I want to make sure I read it as 8 hundredths. Or sorry, I'm so sorry, 8 thousandths. Sometimes we make mistakes in front of our students, and it's okay. It's a teachable moment. So remember, it's 8 thousandths because the 8 is in the thousandths place. So there's another way that students may see this written and that they will have some practice and exposure to. And that is if I connect this to fractions, because we want to start to help our students make that connection between decimals and fractions So I'm going to show you how to write this in expanded form, but using fractions. So again, with my whole number, 4, very much the same. So then when I go to that tenths place with that 6, there's a 6 in the tenths place, and I would read this as 6/10. So I'm going to write it exactly the way I've read it, 6/10. And then I will move on to the hundredths place. I have a 1 in my hundredths place. I'm going to write it the way I'm going to read it. I would read this as 1/100th, so we'll write it as 1/100th, 1 over 100. You can take note of the way my denominators and how they connect to the places that I'm representing. And then my last one is the thousandths place. There's an 8 in the thousandths place, so that 8 is my numerator. And since it's the thousandths place, my denominator is 1,000. But this is another way that it can be written, this decimal number could be written in expanded form. So let me slide my model to the side, because not only are we focusing on expanded form, but we also want to be able to write it in standard form. And some of our students may even say, you know what, that already looks like it could be standard form, even though it's in a place value chart. But this can help us also as we're reading the decimal when it's written in standard form. So I'm going place by place. I have a 4 in the ones place, decimal point between ones and tenths. I have 6/10, 100th, and 8 thousandths. So how would I read this if I was going to read it in this format? So I'm going to start with what's in front of the decimal. It's a 4. So I'm simply going to say 4. If it was a 134 in front, I would say 134. Or if it was 24, I would say 24. But in this case, I'm just saying 4. For the decimal point, I'm going to say and. So right now I have 4 and then I want to read everything behind the decimal almost as if it's its own number. It's not. It's part of the decimal number, but we're going to read it that way. So I have 4 and 618. 618. You want to be careful not to say and again during this part, because the only and is that one decimal point. So 4 and 618, and the last digit's in the thousandths place. So I would read this as 4 and 618 thousandths. If I only had, say, 2 digits after the decimal, I would read this as 4 and 61, and the last digit's in the hundredths, so it would be hundredths. So I could say 4 and 61 hundredths, and this would be 4 and 618 thousandths. So one more format that students may see looks like this. I'm going to put my other one below so you can kind of see it as a reference. And students may see expanded form written this way for a decimal notation. And they may be asked to take this and write it in, could be expanded form with decimal notation, but it also might be to write it in standard form. So I'm going to use grouping symbols and kind of what I know about expressions to help me here. I see 8 times 1/10 plus 3 times 1/100th. So I'm going to place some parentheses around the 8 times 1/10 and the 3 times 1/100th or 100th. So as I'm writing this, I'm going to go ahead and write it in, again, in standard form, 8 times 1/10. So that tells me that there are 8 tenths. 8 tenths. And I know that the tenths place is right after the decimal. So that tells me that there's going to be an 8 in that tenths place. I'm going to go ahead and put a placeholder 0 here for the ones place because I do not have any ones. And then again, the plus sign, if I was writing this in expanded form, I'd put a plus sign and go ahead and represent this. But I want to focus on standard form right now. So when I see 3 times 1/100th, students may immediately assume, oh, whatever's next is what comes next here. In this case, yeah, it is. The hundredths place is next. But what if it was 8 times 1/10 plus 3 times 1,000th? We want students to really notice and pay attention to what fraction is in that number, and that there could be a placeholder 0 between. In this case, there will not be. So 3 times 1/100th, that tells me that there are 3 hundredths, or a 3 in the hundredths place. I know that one place after the decimal is the tenths, the next place is the hundredths, and I'm going to place a 3. So again, students are not simply just seeing expanded form in this one decimal notation format. They will also see it in that equivalent fraction format and this format as well. Let's shift our focus to IOA 4B. Represent, compare, and order decimals to the thousands place based on the meanings of the digits in each place, using greater than, equals, and less than symbols to record the results of comparisons. First, let's take a look at comparing decimal numbers to the thousands place. So take a look at this problem. Jesse and Lyric were competing for the quarterback position on the flag football team. To determine the winner, they wanted to see who could throw the football the farthest. Jesse threw the football 5 1/10 meters. Lyric threw the football 5 100 meters. Who threw the football further? Justify your thinking. So let me think about what's happening in this problem. Jesse and Lyric are both competing for a quarterback position on the flag football team. To determine the winner, they are seeing who can throw a football the farthest. Jesse threw the football 5 1/10 meters, and Lyric threw the football 5 100 meters. I am trying to determine who threw the football the farthest, and I also need to justify my thinking. So I'm going to use a number line to help me determine who threw the football the farthest. First, I'm going to draw an open number line, and I want to give myself plenty of space, so I'm going to draw out the length of the paper. When I look at the distances Jesse and Lyric threw the football, I see that both distances have a 5 in the ones place. The ones place is the greatest place value position in both decimal numbers. When considering the whole number side of the decimal number, I know that the boys' times are greater than 5, but less than 6. I need to place 5 1/10 and 5 100 on my number line to determine which distance was the farthest. Since the ones place had the same value in both numbers, I'm going to have to look at the next largest place value position, the tens place. Before I do that, I'm going to go ahead and set this up. My 5 holes here and 6 here, because I know that both are greater than 5 holes, but they're less than 6 holes. So now I'm going back to look at the next largest place. I'm going to go ahead and write these up here just to make them a little bit easier to see. Okay. So if I'm comparing, so I'm trying to figure out who's larger, or sorry, who threw the football farther. There's a 5 in the ones place again, and both, that's not going to help me. So I need to look at the tenths place. So I know that the tenths place is 1/10 the value of the ones place, and I'm going to partition my line into 10 equal parts between 5 and 6. So I always kind of like to start with a midpoint. So it's easier if I start 5 and then move on to 5 1/10, 5 2/10, and so on. Just need to make sure that the space between each tick mark is going to be equivalent. So I know that this is going to represent the midpoint, or 5 5/10. So I'm going to go ahead and think about that. I'm going to label in between here 5 1/10, 5 2/10, 5 3/10, 5 4/10, 5 5/10. I'm going to keep that space about the same. I am estimating 5 7/10, 5 8/10, 5 9/10, and then 6 holes. So I'm ready to begin placing points on my number line to represent the distances Jesse and Lyric threw the football. Jesse threw the football 5 1/10 meters. So I'm going to go ahead and place the point on 5 1/10 on my number line. I'm going to place the point here. And I know that this is the length of Jesse, so I'm going to label it Jesse. Now, when I look at Lyric's distance of 5 100, I see that there is a 0 in the tenths place and a 1 in the hundredths place. So when I think about what I know about powers of 10, I remember that when I partitioned the number line into tenths, there were 10 spaces, and I can apply the same understanding when I partition to hundredths. There would be 10 spaces between each tick mark, so I can partition the space between 5 wholes and 5 1/10 into 10 equal parts. So I can determine where 5 1/100th would be placed. If I do a midpoint, I know that's going to be 5 5/100ths. So I know that if I'm starting with 5, that very first space there would be 5 1/100th, and this is lyric. I could go ahead and zoom in on this part on a larger number line to really show my students that there are 10 spaces between 5 wholes and 5 1/10, and that would represent those hundredths. But for the sake of space here, I'm going to show you where that would be. So when I partition the space between 5 wholes and 5 1/10 into 10 equal parts, I can just go ahead and label lyric's distance here. I know it's going to be really close to that 5, but not quite there. And I can see on my number line that Jesse threw the football farther than lyric. I know that 5 1/10 is greater than 5 1/100th. So then I justified my answer by using a number line. So let's shift now to thinking about ordering decimals. I'm going to slide that away, and I'm going to use a new problem. Let's go ahead and read this problem. So again, we just did some comparing, and now we're going to shift to ordering. Again, as I stated earlier in this video, we're really kind of using the same strategies that we would use for comparing to order. We're just extending it to 3 decimal numbers from using 2. I am going to use a different strategy here, though. So this problem says, Mr. Gavin's students competed during PE to see who could run the 50-yard dash the fastest. The top 3 students are listed in the table below. Which student in Mr. Gavin's class ran the fastest? So before I just jump in and try to grab the numbers out here, I want to think about what's happening on this chart. So I kind of want to really make sure I take a moment to just really think about what's going on here. So I see that the first student, 1, ran the 50-yard dash in 7 408,000 seconds. Devin did it in 8 seconds, 8 2/1000 of a second. Trey did it in 7 425,000 seconds. So in this case, again, I'm trying to determine who did it the fastest, and I guess also who did it the slowest. So as I'm thinking about each of these times, I'm going to use a place value chart to kind of help me determine who did it the fastest. Now, I know that when I'm trying to determine who's the fastest, I'm looking for the smallest decimal number, because the smallest number here would represent the fastest time. The lowest time is the fastest time, because it means that someone did it the quickest or the fastest. So I'm going to go ahead and think about when I'm comparing, I want to go ahead and place these decimal numbers into my place value chart, and that's going to help me make a comparison, make the comparison so I can order them and determine who was the fastest. So first, I'm going to go ahead and place Juan's time in. I see that there's a 7 in the ones place, the decimal, and then 4 in the tenths, a 0 in the hundredths, and an 8 in the thousandths. So I'm going to go ahead and look at my place value chart. I see here's my ones. I'm going to place the 7 ones, 4 tenths, 0 hundredths, and 8 thousandths. I'm going to do the same thing for Devin and for Trey. Devin had 8 ones, 0 tenths, 0 hundredths, and 2 thousandths. And Trey had 7 ones, 4 tenths, 2 hundredths, and 5 thousandths. So to help me compare, I want to really make sure that I've got these lined up. So that's what the place value chart's helping me do. So I'm trying to determine who's the fastest. So I'm going to start with the greatest place value position of the numbers I am comparing. So when I look at the ones, I can see that Devin had 8 ones. And let me go ahead and write everyone's name over here so we can make sure that we don't forget who is who before I keep going. Juan, Devin, Trey. So I can see that Devin has 8 ones compared to Juan and Trey who only have 7 ones. So this tells me that Devin was the slowest. That's his time is the highest. And remember, lowest time equals fastest time. So I know already that Devin is the slowest. So I'm going to go ahead and write Devin's time. I'm going to write it, can't see. There we go. I'm going to write it here. And watch what I'm going to do next. So then I'm going to move to the 10th place. So I've already got Devin. Devin's done. He was the greatest. Then I'm going to move on to the 10th place. So I can see that Juan and Trey both have 4 tenths. I'm no longer looking at Devin because we've already placed him. We know he's the slowest. So I'm looking at Juan and Trey. Well, both of their times have a 4 in the 10th place. So this is not going to help me. So I need to keep going and move over to the 100th place. I can see that Juan has a 0 in the 100th place, and Trey has a 2 in the 100th place. Again, the lowest time or the smaller decimal place here is going to tell me who was the fastest because the lowest time is the fastest. The smallest decimal is the fastest. So I can see that Trey was not quite as fast as Juan because Juan's number is lower in the 100th place. He has 0 hundredths compared to Trey's 2 hundredths. So I know that Trey came in second, and I know that Juan came in first. Again, I want to make sure that I am using greater than, less than, or equal to record the results of my comparison here. Again, I keep saying comparison because although we are ordering, we are using comparison strategies, the same type of strategies we could use with comparing to here with ordering. Because if I was doing this with just 2 decimals, I could still use a place value chart to help me determine which one is greater or less. So in this case, we know that the lowest time is the fastest, but in this case, the lowest time is also the smallest decimal. So 7 and 408 thousandths is less than 7 and 425 thousandths, which is less than 8 and 2 thousandths. So this tells me that the fastest person in Mr. Gavin's class was Juan. Juan was the fastest. So now we're going to shift to IOA 4C, using place value understanding to round decimal numbers to the 100th place. Take note, with this IOA, we are not extending to the thousandths place as we did with 4A and 4B. We are only rounding decimal numbers to the 100th place. So let's take a look at this problem. Maya and her sister want to buy a medium popcorn. About how much money do they need? So again, I want to make sure I take a look at this graphic here. That's going to give me some information I'm going to need to solve this problem. I know that Maya and her sister are buying a medium popcorn. So I'm looking at the prices here. I see small is $4.25, medium $5.45, and large is $5.99. I am specifically focusing on medium, so I need to find out the price for the medium popcorn, which it says is $5.45. So again, this problem wants me to determine about how much a medium popcorn would cost. So when I see that about word, it makes me think I'm looking for an estimate. So I'm going to be rounding to kind of make that estimate to determine about how much money I would need. Sorry, not me. Maya and her sister would need to buy a medium popcorn. So to do this, I'm going to use a number line. So I'm asking myself, to which place values can I round the cost of a medium popcorn? And if I know that a medium popcorn costs $5.45, between which 2 whole numbers is $5.45, or 5 and 45 hundredths? I know that 5 and 45 hundredths is larger than 5, but less than 6. So it falls between a 5 holes and 6 holes. I'm going to go ahead and create my number line. I want to make sure it expands the length of my paper so I have plenty of room to work. And I know that 5 and 45 hundredths, or $5.45, is between 5 holes and 6 holes. So to help me place 5 and 45 hundredths on the number line, I'm going to determine what decimal number is halfway between 5 and 6. So I know that 5.5, or 5 and 5/10, is halfway between 5 and 6. I'm going to go ahead and label that. So now I'm wondering how 5 and 45 hundredths compares to this 5 and 5/10. So to do this, I'm going to go ahead and write 5 as 5, still 5 equal to 5, but 5 with 0 tenths and 0 hundredths, which is equivalent. And do the same for the 6 holes. And here, I'm going to add a 0 into that hundredths place because I don't have any hundredths. You see, I'm sort of mirroring the number of places I have in 5 and 45 hundredths, or $5.45. So I'm ready to determine where that 5 and 45 hundredths falls on the number line, and if it's closer to the 5 or to $6. So I know that 5 and 45 hundredths is slightly less than 5 and 50 hundredths. So I'm going to place it just to the left of that 5 and 50 hundredths, or that midpoint. So this shows that the 5 and 45 hundredths is closer to 5 than it is to 6. So if I was rounding to the nearest whole number, 5 or 6, I would know that a medium popcorn would cost, let me write that down. And if I was rounding to the nearest whole, which is what I did here, then I know that $5.45 would be about $5. But I'm trying to figure out how much money Maya and her sister would need to purchase a medium popcorn. And I know that they will need more than $5 because the price of the popcorn is $5.45. So I'm going to need to round the price of a medium popcorn to a different place value. I'm going to follow the same process with the number line, but this time I'm going to round to the nearest tenth. So when I round to the nearest tenth, I can see that 5 and 45 hundredths is closer to 5 and 5/10. Remember, that was the equivalent, or 5 and 50 hundredths. So we know that a medium popcorn costs about $5.50. If I was rounding to the nearest tenth, and the closest tenth that 5 and 45 hundredths is to 5 and 5/10. So I know that the nearest tenth would be 5 and $5.50, or 5 and 50 hundredths. I can purchase a medium popcorn. My and her sister could purchase a medium popcorn for, if they have at least $5.50. They would not have been able to do that if they had only $5. And so having this conversation with students really helps students determine what's the most appropriate place to round a decimal based on the context of the problem. So we may have students who would round to $5. And of course, they may do all the work correctly. They may use the number line correctly. Definitely nearest rounded to the nearest whole to be $5, but it won't answer the question. So we want to make sure that we really consider the context of the question and not just grab the numbers and begin rounding or solving the problem. Really want to connect it back to what it's asking. And in this case, it's asking us how much money we need, or they need, in order to buy the popcorn, and they would need about $5.50. Our last IOA again in this unit is 4D, solving authentic problems involving addition and subtraction of decimal numbers to the hundredths place using a variety of strategies. So let's take a look at this problem. How can you determine how much more precipitation Olympia, Washington receives than Salem, Oregon? So I need again to look at my infographic here. Average precipitation for November through January. And I can see in Washington, there was, Olympia, Washington, 23 and 89 hundredths inches. And in Salem, Oregon, 19 and 29 hundredths inches of rain or precipitation from November through January. So I'm trying to determine how much more precipitation Olympia received than Salem. So again, the natural tendency here might be to jump for a keyword. We want to steer clear of keywords because sometimes students might see the word more and they think we're supposed to add, but that's not always true. So here we really want to think about the context. We are comparing the precipitation in Olympia, Washington with the precipitation in Salem, Oregon, and trying to determine how much more precipitation occurred here than here. So when we're making a comparison, we are subtracting. So that is our focus. We want to make sure that students understand that we are comparing, and that is why we're subtracting. So let me go ahead and set up the problem by writing an equation. And so again, we are comparing how much more precipitation was in Olympia, Washington than Salem, Oregon. So that tells me I'm going to start with my larger decimal. And then I'm removing the precipitation from Salem, Oregon to find out the difference or how much more occurred in Olympia, Washington. I'm going to use a symbol for the unknown because we do not yet know the difference between Olympia and Salem's precipitation. So that N represents how much more rainfall fell in Olympia than in Salem. So I'm going to use a number line to help me subtract the two decimal numbers. I'm going to, again, make sure my number line spans the length of my paper to give me plenty of room to work. Something we want to make sure we keep telling students. Sometimes those logistical pieces can be the most challenging for students. So to make this more efficient, I'm going to decompose the number I am subtracting. So again, I am taking this amount away from this decimal number. So I am taking 19 and 29 hundredths away from 23 and 89 hundredths. I'm going to go ahead and decompose 19 and 29 hundredths by place value. I'm going to do that right down here below. So again, my equation, giving me some extra workspace. I'm going to go ahead and decompose. So I know that I have a tens place, a ones place, my decimal, and then I have a tenths and a hundredths place behind the decimal. So I know that this 1 is in the tens place, so it has a value of 10. I know that this 9 is in the ones place, so it has a value of 9. Again, I'm writing this in expanded form because I'm decomposing. My 2 is in the tenths place, which is 1 after the decimal. So again, I use that placeholder 0. And then 2 in the tenths place. I'm going to do that again. Placeholder 0, but this time I need a placeholder 0 for my tenths place, and I have 9 hundredths. So why am I doing this, you may ask? Well, I'm going to be removing or taking away or counting back each of these values from 23 and 89 hundredths, because that's why I'm removing each of these, which is 19 and 29 hundredths decomposed, because I'm trying to find out how much more rain occurred in Olympia than in Salem. So first, I'm going to start with I'm going to go ahead and write on this side the number I am taking from, and I'm going to be counting back. So first, I'm going to take away my 9 hundredths. I'm going to take a hop here. I am removing 9 hundredths. So I'm going to look at that hundredths place. I have 9 hundredths in this place, and I'm about to take all of those hundredths away. I'm not removing anything from any other place but the hundredths place. So this should leave me with still two tens, 3 ones, 8 tenths, and now I have no hundredths because I have taken 9 of them away. So then I'm going to look at the next largest value, and that is the 2 tenths. And I'm going to remove 2 tenths from this number. 23 and 80 hundredths is how much I have left so far. Still counting back because I am subtracting. I'm removing the 2 tenths. So again, I'm going to focus on my tenths place. There are 8/10. If I take 2 of those tenths away, that would leave me with 6/10. So again, I did not remove anything from my hundredths place, did not remove anything from my ones and tens. So again, still have my 2/10, my 3 ones. I removed 2 tens, so that leaves me with 6 instead of 8, and I still have 0 hundredths. So I now have 23 and 60 hundredths remaining. I'm not done yet. I want to keep going because I still need to remove my 9 wholes, my 9 ones, and that 110. So I'm going to go ahead and subtract 9 ones from 23 and 60 hundredths. I have 23 wholes. So I'm thinking of it almost together at this point. And so if I subtract 9 from 23, I know that that would be 14. But an easier way I might think of that is if I know that 9 is close to 10. So I'm going to use a friendly number. So 23 minus 10 would be 13. But I need to count up 1 because I only took 9 instead of 10. So if 23 minus 10 is 13, count up back 1, that would leave me at 14. So that leaves me with 14 and 60 hundredths. I could have if students need support with that, you could decompose this into a 5 and a 4, or it could be, in this case, since this is a 3, it could do a 3 and a 6. It just helps our students see that it is flexible how we choose to decompose. This is what's working for me, but your students in small group may want to see may need to see this decomposed even further. So finally, I'm ready to subtract those 10 ones. Sorry, 10, that 110, not 10 ones, that was in the tens place, that 110 from 14 and 60 hundredths. So I know that if I take 110 from 14, that will leave me with 14 minus 10 would be 4, and I still have my 60 hundredths. So I know that Olympia Washington received 4 and 60 hundredths, or could also write this as, let me come down here. I know that they received, I'm going to write my equation again. I could write this as 4 and 60 hundredths, or I could even write it as 4 and 6/10. So it tells me Olympia Washington received 4 and 60 hundredths, or 4 and 6/10 inches more rainfall than Salem, Oregon. So how would this look different if I had been adding instead of subtracting? I would have started on the opposite side, the left side, and used the counting on strategy, and it would have been counting on in the other direction. Students do have prior knowledge of this from 4th, 3rd, 2nd, and even 1st grade. So it's not their first time counting on or counting back on a number line. But the operation I'm using really determines which side of the number line I'm going to begin when I'm adding and subtracting. In mathematics, the emphasis is on reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. So which strategy? Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. Thank you for watching. Please use your phone to scan the QR code on the screen or go to the website shown to get your completion credit in PD&E.